Handful of extra concepts to finish things off with. What we're going to do now is, instead of thinking about things the way that we did in the previous part of this lecture, we're going to kind of switch around and think directly about conditional probability. So now let's think in terms of sets. Here's a diagram. Here's A, here's B, and here's a way to think about the probability of A given B. We want to know the probability of A given B. In other words, what fraction of the B area is A as well? Here's the B area. Here's the fraction of the B area that's A. What fraction is this area here of this? That is the conditional probability. So what it amounts to is the probability of this area, the probability of A intersect B, which is 0.2, divided by the probability that goes with this area, that's 0.5, and so the answer is 0.4. This is the formula for conditional probability. The probability of A given B is the probability that A and B both happen divided by the probability that B happens. Now this actually follows some things we've said before, but this is another way of seeing it. Likewise, the probability of B given A. We're asking, within the A area, what fraction of that A area is also B area? So what's the ratio of this, the AB area, the A intersect B area, to this, the A area? The probability of B given A is the probability of A intersect B, 0.2, divided by the probability of A, which is 0.3. And so it's 2/3 or 0.666. So this actually says things that in effect we've said before, but it puts them in a different way. It gives you a way to think about things now, starting from conditional probability. And notice, in fact, when I say that it's the same thing that we've seen before, we can check that out. The probability of A and B, we said, should be the probability of A times the probability of B given A. Well, the probability of A is 0.3. The probability of B given A is 2/3. 0.3 times 2/3, that's 0.2. So it all fits together. This works out. We could look at it the other way around. The probability of A and B is 0.2 as before, but just switching the order here, it's the probability of B times the probability of A given B, and that's 0.5 times the probability of A given B, which is 0.4. Once again, it's 0.2. All of this actually is just a couple of steps of algebra from here to here, but this lets you see that the picture we get when we think in terms of conditional probability fits together with what we said when we started out by thinking about joint probability. So this is important. We have general relationships here, general relationships here, but rather than simply memorizing them, the thing to do is think about their logic, think about why they're true, think about how they fit together. Now there's one more thing that we want to introduce, and then we'll be done with our basic introduction to probability. What we want to do to finish off here is talk about the law of total probability. We're just putting together a bunch of pieces of things that we already know to come up with something that's actually a very useful concept. So here it is stated, and we'll relate it back to the diagram. First, we know that the set A is the union of A, B, A intersect B, with A intersect B complement. A is what's in A and B, together with what's in A and not in B. So the probability of A should be the sum of these two bits. These two bits don't overlap, they're mutually exclusive in logic terms. So the probability of A should be the probability of AB plus the probability of AB prime, and it's as plain as the nose on your face. The probability of AB is 0.2, the probability of AB prime is 0.1, and in fact that's how we got the probability of A in the first place. So this little formula here is nothing more than what the eye can plainly see. And this is an example of the law of total probability. This is a simple form of the law of total probability. But sometimes, we'll see, there's something to be said for taking this probability of AB and expanding it using conditional probability, taking this AB prime and expanding it using conditional probability. And when we do that, here's what happens. The probability of A, as before, is the probability of AB plus AB prime, but the AB part can be written this way. The probability of A and B is the probability of B times the probability of A given B. All I've done is swap the order here. The probability of AB prime is the probability of B prime times the probability of A given B prime. And now let's look and see what these things are. Well, the probability of A given B we already discussed, but let's just remind ourselves. The probability of A given B is the ratio of this to this, which is 0.2 to 0.5, in other words, 0.4. Multiply that by the probability of B, 0.5, and now go over here. The probability A given not B. Let's look at that. In the not B part of this diagram, what fraction is A? Now the not B part is this region out here and this region here. All this stuff here is the not B part of the diagram. Its total probability is 0.5, but the fraction of it that's also A is 0.1. So it's 0.1 divided by 0.5, that's 0.2. We take the 0.2, the probability of A given B prime, multiplied by the probability of B prime, that's a half. 0.2 times 0.5 is 0.1. Now we add it together and we get 0.3. So this rather long-winded looking expression here is another form of the law of total probability. Now, why, you might ask, would we put it in this complicated way? Well, because behind it is a simple idea. Sometimes the way to figure out how likely A is to ask, how could A come about? What are the different paths that might lead us to A? And so suppose that one way that A might come about is via B. Another way it might come about is via not B. Well, we sort of say, look, A either came about by B or not B. The probability of A and B, that A came about by B, is this piece here. The probability that A came about by not B is this piece here. In other words, we start with the probability of A coming about by B and weight that or multiply it by B's probability. Then we take the probability of A coming about by not B and weight that by not B's probability, or the complement of B's probability, and we simply add them together. Now, from the point of view of shear algebra, all of these are the same thing, but there's slightly different ways of thinking about things. So what I'd like you to do is first, you can go over the lecture again if you need to and make sure that you feel comfortable with the concepts, but then you'll also be given some problems that will let you get more comfortable with this by way of examples.